Hi everyone. Thank you for another day. It's a continuation of the same topic, drawing techniques. So we're still continuing with the drawing techniques. We looked at We looked at the alphabet of lines, and we also looked at concepts like printing and lettering. And today we are looking at copying given figures. So we've got these figures on this side here, and we're going to copy them according to the the given dimensions. For example, this rectangle here has got height or width of 25, and the length is not known, so that length is the one which is given here. And also for B, we're given the height, same height, 25, but this side now is inclined at an angle of 45 degrees. And we are also shown on the question how these lines are to be drawn. For example, this rectangle here, we are given that it will be drawn using this angle, which is 90 degrees. So you'll be using this angle 90 degrees here, and also this side is given just the same, it's 90 degrees. And for this one, it's now drawn at 45 degrees, which means you are going to use a 45-degree set square to draw that. Right, so I'm going to start with A, which is a rectangle. This is C. Right, we are given that side, which is this one here. So we are going to just to construct a 90-degree angle, or draw a line at 90 degrees from both corners, this one and that one, which means from here we are going to draw a vertical line at 90 degrees, and the height we are going to measure 25, and then we will finish off. As simple as that. So you know how to use the set square and t square together. So I'll put my t square there, and then my set square like that, and that's now we are going to use 2H pencil, which is for construction. So assuming that this is my 2H, I'll do that. And also this side, unfortunately it's not visible enough because I'll go over it in black, so I don't want it to be that bold, but I think you are watching what I'm doing here. You draw, construct a line for 90 degrees, and also another one here at 90 degrees, like that. So that's my 90-degree line, and then after that you are going to measure 25. You use your ruler to measure, or you can mark off using a pair of dividers. You can mark off those distances using a set square, which means using a divider. You mark off 25 from the ruler or from a set square, and then, or you can just measure it directly there, 25 millimeters. But now, since that is not exactly 25 millimeters, I'll just use a pair of dividers. I'll do this to mark off this. I mark off that distance there, and then I mark it on one of those vertical lines. So it's somewhere there, like there. And then you now complete your drawing by outlining. So that's where my 25 is, and you outline like that, and then you continue outlining, going over the 2H lines that you constructed, like that. and also here, like that. So we've copied that rectangle onto the given space. So now I'm going to erase those unnecessary constructions, and then coming to B is still more the same height, and then the angle of 45. So since it's the same height, we'll just use a t-square to transfer it. But here you have to construct a line at 45 degrees from this corner and 45 from that corner, like this. Faintly, so I'm going to use red as my construction, like that, and then also another one from this other end, 45, right? And then I just use the given one, which is 25. I'll just transfer that using my t-square. Unfortunately, I have to erase that C is in the middle of that drawing there. So I just draw a line in between those two lines to give us the given shape. So I now outline. When outlining, you also use your t-square and c-square like that in conjunction with each other when outlining, like that, and then also here, like that, right? So that's my so that's how you go about it. And then on C is now, oh, I forgot to write the angle there. What's the angle there? C is 60 degrees. 60 degrees. Let me write it down there. 60 degrees. So it means you are going to draw construction lines from each of those points, the end points of the line of the given base, which is this one. That's the one which is given. So from here you draw a line at 60 degrees and also from there at 60 degrees. So my t-square is now short. It can't reach there, but I know how to go about that. So our c-square, our 30 by 60 degree c-square. So this is the 60 degree angle. So I use the t-square as the base, like this, and then I construct a line 60 degrees using 2H, which is light. Unfortunately, my marker is tied up. I have to buy new ones. Yeah, like that. And then I can change it this side so that I can use that side. I wish it was longer than that. And then here also at 60 degrees, like that. And then after that, as you can see, it's still 25. So we just transfer that height using the t-square like that. And then you now outline from here up to there. But since this is short, I'll just use an improvised way of doing it, since I know like that. So that's our I can't tell whether it's a rhombus or a parallelogram because we don't know the length of that other side. If it were a square with all sides equal, it would be a rhombus. If one side is longer than the other, it would be a parallelogram. So that's the solution for number 3. That's how we go about it. And now let me label it because I now have space there. Right, this is C. C, and this is B. Let me write it here closer. B like that. And now coming to the fourth one, which is D. D is an equilateral triangle, I'm sure. Or is it could it be equilateral? No, I cannot prove that. Well, those sides are not given as the same. So on the answer sheet we are given this base side. So I'll use my my pair of dividers to mark off that distance. So that's the base. So I'll draw it there. Here. So here. Right. Let me mark it. So that's the given side, which is the base. And then we are given that the height is 25. So since it is equilateral, you can see that these sides are equal. And it means if it's an equilateral triangle, it means all the sides are equal and the angles are also equal. So this would be 60 degrees, 60 degrees, 60 degrees, because the total sum of internal angles of any quadrilateral or triangle is 360. So I'm going to use my 60-degree set square. Remember the height. Let me measure the height first. The height is 25. So that's my height, 25. Height of 25 there. So I mark it there. Let me use this one here now. $25. Then so I'm going to draw a faint line there. Let me use green this time. The red is gone completely. I'll just draw height of 25 there. And then I use the given side. I use this given side here. And then I just strike an arc there. So it means that is now the apex. So I join a line from here to there, from here to there. And I've copied my drawing. Right, so I'm going to outline. Right, that's how you go about. I've copied that drawing, so it's an equilateral triangle rather, like that. So that's our C, our D. That's our D. And then coming to E is a right angle triangle, and this is the given base which are given on the answer space there. So I'm going to copy down this onto the drawing space there. Let me use my curve dividers. In a workbook it's already given, so that's why I'm now trying to transfer it here up to there, right? Let me start from there up to there. That's the given side. Right, and then we are given that this side here is at 30 degrees to the horizontal line, or to the horizontal, and then I can use my set square, because these set squares are designed in such a manner that this smallest of the angles is 30 degrees, and this one is 60 degrees, this one is 90. So I'll use this angle here, 30 degrees. So this angle must be by the base, like that. So I'm going to construct that at 30 degrees, like that. That's my construction, which is red. Which is red, yes. And then this other side is vertical. It's a 90 degrees. So after having drawn that line at 30 degrees, you can now just outline. Now when you draw this other one, it's like this, because you know where it ends. So it's like this now. And then you complete by outlining that other side. Like that. This is DE. It's now E. And then F. F is a trapezium. This line is the one which is given on the drawing space. So I'm going to consider that length first of all. Let me label it F. Right. So let me mark off my distance there. There it is. So mark off that. So this is where it starts from. And it ends there. So that's the given side of the trapezium, the base side, and we are given that the height is 25 and the angle is 60 degrees. So you can start by marking the 60 degree angle there. Let me just use my ability to do that. So this is your T-square, and then remember the T-square must always be in contact with the T-square, like that all the time. Don't let your C-square slip underneath, or it should leave a space like that. It must rest fully on the T-square like that. And then I have my line at 60 degrees like that as a construction. And then I'm going to consider now a vertical line from here, which is that angle 90 degrees. So 90 degrees from here, you draw a line at 90 degrees. Let me do it faintly first. So my 25, let me mark off my 25. That's my 25, but if it were a ruler, I would mark off from a ruler, but I'm simply copying those. So now that's my 25 mark there. There, right? And then after that, I now draw a complete figure, which is a trapezium. And then let me just outline, but you use T-square and C-square like that. And then you complete it by outlining using HB pencil, so that is dark like that. So that's our our trapezium. You are not going to show any dimensions there, or like 30 degrees, 60 degrees, 25. You are not to do that. You are simply copying the figures. And then coming to G, G is G, and you are given 60 degrees. Let me show it here. Even though it's not given as 60 degrees, but on the answer sheet there is given like this, whereby you are going to use the 60 degree angle to draw that, and also 60 degree to draw that. So you are given the shape of the let me start with this one here. It's given like that. So this is the 60 degree angle, and that side it will be flipped around like that. This is the, so this is the 60 degree angle, this is the 60 degree angle. So which means this line is drawn using that, and this line is drawn using that 60 degrees. So it's also an equilateral triangle. So first of all, let me copy down the given side or the given base. Right, let me mark off the base there. I've measured 20, the dimension there. That is FG. FG. Right. So that, let me measure exactly. Right. So that is my given side or given base of the equilateral triangle. So I'm going to use 60-degree side of the set square like that from either end. First of all, you did faintly, which means you use 2H. You use 2H. Okay. You use 2H. So I will now be using green as my 2H. And also this side, we flip it around like that. And then here I can now use my HB, which is black now here. So I can just simply outline like that. And then this one I can go right now with HB like that. And that's my triangle, which is equilateral. Right. So this is the equilateral triangle. This one is not equilateral here. It should be an isosceles triangle, because these two angles will be equal. Let's say it's theta, and also this one is theta. Then this one will be, say, alpha. Right. So the two base angles will be equal because that height is the one which has resulted into that. So this one is an equilateral triangle because we use the 60 degrees to construct this and also that one, which means this one definitely is 60 degrees as well, because sum of interior angles of a triangle add up to 360. So we're now moving on to the next one, which is H. H. Let me see where I can write it. I think here. H. H is a hexagon which has got 6 sides, and it is a regular hexagon. All the sides are equal. And then let's see how the hint is telling us. That's H is 60 degrees. These lines are drawn at 60 degrees. This line and that line there are drawn at 60 degrees. And also that one at 60 degrees. Is indicated on the drawing space because they've used the set squares just like this to show that. So we're going to first of all draw the given side. So I will mark it off from the given diagram there using my dividers, pair of dividers. So that's my given side there. Okay, that's it. And then I draw it here. Let me show it here. The given side. Let me push it up here a little bit. Let's hope it will fit right. So it's there and there. Right, so I'm going to have that line as a bold line because that's the one which is given there, and it's a definite side like that. So from those two ends of the line, I'm going to construct lines at 60 degrees going outwards. So this one will be drawn using that, in that direction rather. So I construct that, and also here I flip around the T-square, I mean the C-square like that, and it's like that. And then after that, as you can see, this one is now vertical. But to determine that length from here to there, you have to mark off that distance. You see? So now, before that, we are given these lines from one corner to the opposite corner there. So these lines are drawn at 60 degrees from those corners as well. So after having drawn the edges of the hexagon, you also have to draw this at 60 degrees as well. So it's like this. From there, at 60 degrees, you flip around. This one also at 60 degrees, like that. And then after that, we can now consider the same height, I mean the same length of that side. You mark it there and you also mark it there. So let me do that now. This is the same length, so I mark it here and also mark it there. Right, so that's where the lines are. Then from here I draw a vertical line, like this. My dimensions are not accurate because I'm using that improvised pair of dividers. So I draw a vertical line there, going up there, and also here. It's not coming out accurate like I see here now. And then I mark off the same distance, this same distance here. I mark it off here. It's right there and also right there. So it's up here and up there. Unfortunately, it doesn't come out accurately because these lines were supposed to come out right at the corner there. But once you miss accuracy there, it's going to be like that. GH. So I think the accuracy of the sides are the ones which gave me that inaccuracy. Anyway, this was supposed to come and meet there. And then what else now? We have to draw. This was supposed to meet somewhere there. This was supposed to meet somewhere there. I'm sorry for that inaccuracy. And then from there, as you can see, this is a line which is parallel to this. So it has been drawn at 60 degrees. Should be 30 degrees, not 60. Like that. I have to do this on its own again. It's not coming out properly because the measurements that I'm using here. Let me redo this afterwards. Let's forget about it in the meantime. Let's forget about it in the meantime. Let's do it's H. What am I doing? It's HGH. I'm confusing. I'm doing that one there. Oh, that's why, man. Sorry, I confused. It's H, not G. I'm mixing up the angles there. That's why. Sorry. So it's H is this one, not that one. Oh God. So it's this one. I was taking this one. It's this one here. Sorry. Yeah, it's this one here. H. Somewhere there. Right. So it's right. That's the given side of the hexagon. That one there, H, not this one. Sorry, it's that one there. And then, according to the hint there, as you can see, this line is drawn at 60 degrees, according to what's given there. H drawn at 60 degrees. So this line is drawn at 60 degrees, this one at 60 degrees. Right, like that. And also this one at 60 degrees. Like that. I have to remove that label. H. Right. Then from there now, we are going to have the same side. This one here is the same as that because it's a regular hexagon. And on this one, you can also draw this at 60 degrees from those corners. At 60 degrees. Like that. And then, as you can see, this line is passing through the intersection of the two there. So if you draw a line like this, it will give you the other corners of the hexagon, like that. And then from here, you draw another one parallel to this, which is at 60, at 60 degrees. That internal angle should be 60, and here also that way, this one must be 60. So $60 like that. I can use my black, my outline 2H, HB outline, and then it will have to intersect that one there, like that. And then also on this side, you flip it around like this to intersect that other one there. And then the last line there is just a matter of using your T-square like that. Come on. Like that. That's our hexagon. You erase all those other protruding lines. Right. So that's our hexagon, which is H. And then coming to I looks like a square. It looks like a square there. That's a square, and all the sides are equal. Therefore, we draw the given base according to the answer requirements. So you are given the bases. So that base, I'm going to draw it here. Let's measure it. Is it visible at the bottom there? So I'm going to draw that side, the given side. This one here. Right. So just join them. Let's look at the short one. What is it? What's this? T-square. So that's our given side of the square, and as you can see, this is at 90 degrees, right? So I construct lines from either end of the line vertically, like that. And also this side. Like that. And then since it's a square, all the sides must be equal. And I'm going to use my 12 dividers to mark off this, and then I mark it there just a one on one line. It's enough because you are going to use a t-square to transfer that. And you use your t-square like that. Let me finish off using this. So it will be a t-square. We have to use blue here. Is my outline. Black is also dried up. So that's our square, which is HI. It's I. Right. Outline this. Right. Right, now coming to the one that I was mixing up.